In the previous weeks, we looked at how we can create a design of our system. You were introduced to important concepts like creating a modular and layered design and how we can use modeling languages like UML to represent these designs. Now that you have started developing or writing code for your system, it is once again important to take the big picture view in order to make sure that everything is going along as intended. This is the software architecture. Software architecture is a way of organizing your code. How should different classes or modules be organized? It is actually similar to building the architecture of any product. So, there is an efficient way in which an entire building or a house is constructed. There is efficiency of space, efficiency of functionality and so on. Software architecture is quite similar. It defines the software elements or modules, the relations among them and the properties of both the modules and the relations. Now, this might all sound very abstract, so let us see some examples. So, here is a reflection spot. Let us take an example of two software systems, Google search engine and another which is a compiler. If we consider these as software systems, what are some key differences between these two systems?
So what is the difference between a Google search engine type of software system and a compiler software system, right? So let's look at Google search. So Google search is essentially a web-based system. So when I as a user type a search query, a request goes to one of the servers of Google and Google returns a response which returns pages related to my query. And these type of systems are commonly known as client server systems where data transactions happen in response to requests. And you might know that this is predominantly how the internet functions today, right? So this client server system is a type of software architecture where there are systems which behave as clients and other systems which behave as servers. Now let's look at a compiler, right? So what does a compiler do? A compiler, it takes source code as input and then transforms it into what is known as assembly code and then again transforms this into an executable file which can be run by the underlying operating system, right? And this type of software system is known as a pipe and filter type of system where data is passed from one component to the other component and it is transformed and filtered along the way. So if you have noticed, this client server type of system, which is like a Google search engine, is different from a compiler system, which is a pipe and filter type of system. So the interactions which the different components have with each other are different. So in a client server model, the client and server, they communicate with each other through requests and response. Whereas in a pipe and filter type of system, data is passed from one component to the other. So these types of patterns of information between different components, they are known as software architecture styles. So let's look at some more examples to highlight this concept. Another type of software architecture is known as the model view controller or the MVC type of architecture. So in this style, the views of the data are separated from the manipulations of the data. So let's look at this MVC architecture. So M stands for model, which is usually the component which models the data required for the service. So for example, in the case of the Amazon seller portal, the model is nothing but the classes or the objects which model the tables in the database. Now the view component is nothing but the GUI objects, the presentation layer, or the visual representation of the model. For example, how information is seen on a particular website. So the view component, it retrieves data from the model and displays it to the user. And it also passes requests back and forth between the user and the model. Now the controller component, it coordinates multiple views on the screen and helps users manipulate the model. So for example, you can have a filter catalog items which is based on name in the case of the Amazon seller portal, right? So in this case, the controller sends this message to the model, which receives the user input and sends the appropriate messages to its underlying views. Another type of software architecture is known as peer-to-peer or P2P. So P2P architecture is nothing but a distributed application where different systems, they form nodes and they share resources with each other. So unlike a client-server model or the MVC type of architecture, there does not exist a centralized system which monitors all the transactions of the system. So nodes in the network, they make a portion of their resources such as processing power, the disk storage, directly available to all the other nodes in the network without the need for central coordination by servers or stable hosts.
Now, let us examine the common aspects in the different architectural styles that we saw earlier. What is similar? One important aspect of these styles is the notion of a component. Recall from the first week that we said that a software is divided into components. Component is nothing but some well defined functionality or behavior separate from other functionality and behavior. For example, in a client server system, the client software is a component and the server software is another component. Your browser which sends a request to a search engine is a component and the server which responds to the request is a component. Now that we have seen what components are, another important unit of the architecture is connectors. Components cannot function in isolation, they have to be able to talk to each other. These are the connectors. So connectors are code that transmit information between the components. They are responsible for regulating the interaction among the components. Now there needs to be a standard way in which components can interact with each other. These are called protocols. A protocol is nothing but a set of predefined rules which describe how the components should interact with each other. For example, it may be that let us say there is the client component and the server component. Now both the client component and the server component need to understand and agree upon the way in which the message will be transmitted between them, right. It cannot be that the client sends the message in one format while the server is attempting to process the same message in a different format. So the protocol or connector is the understanding between these two components. The most common type of connectors are function calls and REST API calls. You have specific rules to create endpoints which help you communicate with other components. So how do we come up with the components of a software system? In the past, experienced designers consciously reused solutions that have worked in the past. So there would be libraries of various modules and many of these solutions later became standardized and are commonly known as design patterns. So, there are several good books on design patterns. For example, there is one on elements of reusable object oriented software, then there is design patterns and so on. The key idea is a design pattern is a description of communicating objects and classes that are customized to solve a general design problem. So, we will be looking at some design patterns in later videos in this week. Even if we have knowledge of good design patterns, often even with good intentions one might not use a pattern correctly or new code might get added along the way. This is actually known as an anti-pattern. So, this can actually lead to lot of problems in the code. So, now what are warning signs that you may be headed towards an anti-pattern? Interestingly enough, this is called a design smell. So, a key way to avoid such design smells is to follow effective guidelines of software architecture. This is known as the SOLID guidelines, okay, which we will discuss in upcoming videos. SOLID is basically an acronym, okay. S stands for single responsibility, O stands for open closed and so on. So, we will see all these details as we go along. So, when you see that there are design smells in your architecture, moving back towards a good design process is known as refactoring. Refactoring a design involves moving code between classes, creating new classes and modules or removing classes that are not required. We will see how we can refactor code using the SOLID guidelines as we go along. So, to summarize, software architecture is a way of organizing your code. How should the different classes and modules be organized? There are several architecture styles: client server, pipe and fitter, peer to peer, model view controller and so on. Briefly, we looked at some design patterns which are the common patterns of organizing code that have worked out in the past. We also had a quick look at design smells, which is what happens when there are lack of proper design patterns. In the next videos, we will look at guidelines for creating effective software architecture using the SOLID guidelines.